Two datasets of 23 integers each are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10 but less than 20. The second interval represents the frequency of integers greater than or equal to 20 but less than 30, and so on. What is the smallest possible difference between the mean of dataset A and the mean of dataset B? Okay, so these are the datasets where the x-axis shows the integer or the value in the dataset, and then the frequency here shows how many times that integer occurs in the dataset. And we see that they have the same shape, but dataset B is to the left or more to the left than dataset A, which is more to the right. So that means dataset A's mean is larger than dataset B. And if we want to find the smallest possible difference, we need to find the smallest mean of dataset A possible and find its difference with the largest dataset for B possible, because that would give us the smallest possible difference. So the smallest possible dataset A mean that we can find is assuming that all the integers in this range, going from like 20 to 30, that all of them are at 20. And if we do that for each of the intervals, like looking at the boundary, instead of the whole interval to find the smallest possible mean, we'll find the mean that is smallest possible here. So let's do that for dataset A. So dataset A says that we have 3 as a frequency for this interval here from 20 to 30, but we want to find the smallest integers possible, so we'll assume that they're all 20. So we'll have 3 20s. Then we'll add that with 4 30s and then 7 40s and then 9 50s. And that will all be above 23 since each has 23 values. So this will give us the smallest mean possible for dataset A. So let's put that into our calculator and find the mean. So 3 times 20 plus 4 times 30 plus 7 times 40 plus 9 times 50. That's equal to 910 divided by 23. And that's about 39.56. 39.56. So that's the mean of dataset A. Now let's do the same thing for B, but this time, since B's mean is smaller than dataset A, since B is including values from 10 to 20, so it's like the dataset of A, but shifted a little to the left, making the mean smaller. We want to find the largest possible mean for dataset B. So then we'll use boundary points on the right side instead. So here in this range from 10 to 20, it's saying that there are 3 values. But instead of using values that are small, we'll use the largest possible. So the largest possible in this interval are 19. And the largest possible in this interval are 29. The largest integers possible in this interval are 39. And the largest possible integers in this interval are 49s. So we'll use those for the value for the means. So we have 3 19s plus 4 29s plus 7 39s and then plus 9 49s. And we'll all divide that by 23 to get the mean, since there are 23 total integers in each data set. And if we put that into our calculator, 3 times 19 plus 4 times 29 plus 7 times 39 plus 9 times 49, we'll get 887. Divide that by 23, and we get 38.56. 38.56. So this was the largest possible, or the smallest possible mean we could find for data set A, and this was the largest possible mean we could find for data set B. So the difference between these two will give us the smallest possible difference between the means of the two data sets. So, and the difference between these two is 1. So the correct answer choice is B.